So let's now talk about the part of subjective refraction. So the refraction, or how to refract a patient, and is to know what is his refractive error. And this can be done either subjectively or objectively. Objectively by a device that is called retinoscopy, that will be discussed next week in the instruments, and subjectively by other methods that we will going to discuss now. Subjective refraction, meaning that how can we know the spherical and the cylindrical lens power of the patient? For knowing the spherical power of the patient, we have two methods. We have the fogging technique and we have the duochrome test. And duochrome test has been already discussed in the first lecture. While the cylindrical lens, there are different methods to know what is the cylindrical power of the patient. This can be done by a device called the cross cylinder, and another device called the astigmatic dial, or another method called the astigmatic dial, and finally the stenopic slit. So let's start first with how to know the sphere of the patient. Before knowing the spherical error, we should first know that accurate determination of the distance refraction requires suspension of the accommodation. So the patient shouldn't use his accommodation in order not to have a false results of the refraction. And this can be done by two methods. In case of children, you put cycloplegic drugs like atropine or cyclopentolate, and this is a must for refraction of all children under 15 years old. And there are non-cycloplegic methods which is reserved for the adults, like fogging technique, in which the adult accommodation is suspended by using a plus lens of increasing power. So let's discuss the fogging technique. What is meant by fogging? A fog, as you all know, is a substance present in the air that will make the vision cloudy. So if you are having a foggy atmosphere and you are driving your car, you will not be able to see the road and the areas around you. And this is what happens exactly in case of fogging of patient's vision using the fogging technique. We want the patient vision to be blurry. And by making this blurry vision, the patient will be forced to abort his accommodation and not to use his accommodation. So this is the commonest non-cycloplegic method to suspend accommodation. This can be done by putting a high plus lens in front of the patient eye, and this will bring the f2 of the eye into the vitreous cavity until the visual acuity is less than 636. So let's see how this is done. So we have here the lens of the patient. This lens of patient can cause accommodation, and this accommodation will lead to false results in case of doing refraction of patient. And that's why we put a plus lens, a strong plus lens. This strong plus lens will converge the parallel rays, making them falling into a focus. This focus, we agreed that it is f2. This f2, instead of being on the retina, it will be on the vitreous. So what happens next? If the focus of the image will be in the vitreous, then it will be blurred, and then the patient will not use his accommodation, because if he uses his accommodation, this will bring the f2 more closer to the lens instead of being more further toward the retina. So by this way, we ensure that the patient is not using his accommodation, and the accommodation will be completely relaxed. So we use a high plus lens in front of the eye to bring the f2 of the eye into the vitreous cavity until the visual acuity is less than 636. So what happens next? Then the power of the lens plus lens is gradually reduced. So if we are using, for example, plus 5, then it will be plus 4.75, then plus 4.5, then plus 4.25. We gradually decrease the plus lens until the f2 of the patient gradually move toward his retina. So until they reach his retina, then the image will be focused and the vision will be clear, and the patient will report that this is the best vision he can attain. And by doing this, we can, for example, if this F2 on the retina and the patient reach the clearest vision with the F2 on the retina with the +3, then the patient's spherical error is +3. So this is theoretically, but in practice, when we are doing this test, we just or the actual use of this test is after obtaining the retinoscopic reading, and we want to know that if this reading is accurate or not. We do what's called the +1 diopter test. So +1 diopter test is we put a +1 diopter in front of the patient's eyes, and then and then see if the patient can see clearly or not. So by putting this +1 in front of the patient eye, either in his retinoscopic reading or in his glasses, over his glasses, then we gradually decrease the power until the patient see the best vision that he can see. So we don't start from far away. We don't start from +10 or +5 or +4. We just put a fogging of just +1 over his previous correction. The second test has been already discussed thoroughly, which is a duochrome test, so we will not go through it again, but we will now move to the methods for correction of the cylinder, which will be the cross cylinder. So we'll start first with the cross cylinder, and this will be the most of this lecture. So when we are doing subjective refraction of a patient, we correct each one of the eyes separately. So we check the sphere, then we check the cylinder. And by checking the cylinder, we mean that we check the axis of cylinder and the power of cylinder. And then we recheck a sphere by the duochrome test. And then for both eyes, we will do what's called the binocular balance and do the near add if it is needed. And finally, we write the final prescription. So these are the steps of the refraction, of the subjective refraction of a patient. Here, in what we concerns us here is the checking of cylinder, which will be by checking the axis and checking the power. So this can be done by a device called the Jacksonian cross cylinder. What is the Jacksonian cross cylinder? Jackson is a scientist that invented a spherocylindrical lens that is composed of two cylinders of equal power and opposite signs. So here, this is a plus 0.5 diopters on this axis, and on the perpendicular axis, there will be minus 0.5 diopters. So this is a lens, a spherocylindrical lens that's composed of two cylindrical lenses of equal power, but of opposite signs and of opposite direction to each other, and both of these lenses are mounted on a handle. And by flipping this Jacksonian cross cylinder in front of the patient, we will be able to know what is the axis and what is the accurate power. This device is invented or designed by Dr. Edward Jackson, this person. And the optics of this, that it is having a spherocylindrical power, as we said. So it has a spherical component combined with a cylindrical component that is twice the power of the sphere and the opposite sign. This is very important in the MCQ. That the cylindrical power is of twice the power of a sphere and the opposite sign. Let's have an example. We have two types of the cylindrical lens. We have the 0.25 and the 0.5. Let's see one of them, which is the plus 0.5 sphere is combined with -1 cylinder. So if we have a spherocylindrical lens of plus 0.5 sphere and minus 1 cylinder, then the net power of this will be plus 0.5 in one axis and the minus 0.5 in one axis, because this will be the same as plus 0.5 and minus 0.5 sphere. So this will be plus 0.5 in one axis and the minus 0.5 on one axis. This is will be by transposition. So this Jacksonian cross cylinder will be equal plus 0.5 minus 1 cylinder axis 90, and this design has been made in order to make the spherical equivalent also 0. So if you have, or if you obtain the spherical equivalent of this equation, so it will be plus 0.5 plus minus half of the cylinder, which will be minus 0.5, then the net result will be 0. So why do we need that the spherical equivalent of this length to be 0? This is because we don't want to change the position of circle of least confusion in relation to the retina in the case of the patient. So let's have this more in practice. If we have a plus length, which is plus 0.5, so both meridians have plus 0.5 diopters, and we combine it on a cylindrical length, which has minus 1 in the axis of 90 diopters, then it will be plus a algebraic summation of both meridians, then plus 0.5 plus minus 1, it will equal minus 0.5, while plus 0.5 plus 0, it will equal plus 0.5. So again, if we have a cylindrical length which has a plus 0.5 cylinder over the axis of 180, and we combine it of a plus 0.5 diopter on axis of 90, then the net result will be the same. So it will be 0 plus minus 0.5, then it will be minus 0.5, and plus 0.5 plus 0, it will be plus 0.5. So a spherocylindrical length which has a power of a sphere of plus 0.5 and the cylinder of minus 1 axis 90 will be the same as two cylinders. Each one will have a plus 0.5 but will be opposite directions or opposite axis. So this will be the same like this. So by transposition, Jacksonian cross cylinder, it can be called a spherocylindrical length that has the cylinder twice the power of the sphere with opposite sign, or we can say that it has two cylinders, each one of them is of the same power but of equal sign. This is the principle of the cross cylinder, because we need the cross cylinder to have a spherical equivalent of 0. Is this concept clear, or anyone have a problem with it? So I guess no news is good news. So no answers or no complaints. Okay, so I guess that we understand this because this is the basic principle of the cross cylinder that we will use in order to adjust the cylindrical power and the axis. So as we said, the Jacksonian cross cylinder has both cylinders. These cylinders are perpendicular to each other. They have the same power but of different sign. So usually these signs are marked. Usually the black one will be the plus cylinder, and the red one will be the minus cylinder. But you have to make sure that this is the case, because it will be written on it. For example, it will be minus 0.5. So you need to know, or you need to make sure that the red one is on the minus side. But because some Jacksonian cross cylinders mark the red on the plus. So you need to make sure of this. And then by flipping the cross cylinder in front of the patient's eye, you will now switch or toggle between the minus cylinder and the plus cylinder in front of the patient eye. Then we have the handle. The handle is between the two marked axes, which will enable us to twirl or to toggle or to switch between the plus and the minus cylinder in front of the patient eye by just a rotation of the handle. And in this position, the minus and the plus axis are interchanged rapidly. This is called the flipping technique, and that's why it is called the flip cross cylinder. We have two types of Jacksonian cross cylinder. We have the 0.5 diopters like this one. So it has a plus 0.5 diopter in one meridian and the plus 0. Or minus 0.5 in the perpendicular meridian. And we have the 0.25. So it will be half of the size of this meridian. So let me ask you a question to see that if you understand or not. If you have a minus half of a cylinder and the plus half cylinder, can you tell me in the toric form what will be the spherocylindrical form of this lens? So if you are asking the exam, the minus 0.5 cylindrical Jacksonian cross cylinder, what is the format of the spherocylindrical form? Can you tell me? No replies? Okay, as we mentioned earlier, if we have two cylindrical lens mounted on together, and then this lens will have a plus 0.5 in one meridian and the minus 0.5 in the perpendicular meridian. If you want to change it to the spherocylindrical form, then it will be the sphere will be that the cylinder will be double the sphere. So it will be plus 0.5 minus 1 in axis 90, or the reverse. It will be minus 0.5 plus 1 over axis of 180. So this is so in case of Jacksonian cross cylinder, it has minus 0.5 diopters cylinder that mount together like here. This will be the same like this. Please concentrate well. The plus 0.5 sphere minus 1 cylinder axis 90, it is the same like plus 0.5 in one meridian and minus 0.5 in the other meridian. And the reverse will be in case of the 0.25 diopters. So if we have a Jacksonian cross cylinder that has 0.25 diopters in one meridian, it will be having a plus 0.25 in the other meridians. I don't understand, Dr. Magid. Again, what is the optical principle of the Jacksonian cross cylinder? The Jacksonian cross cylinder is based on combining two cylindrical lens of the same power but of opposite signs like this. So it will be plus 0.5 and here this is minus, sorry. and the minus 0.5. So it will be the same power but of opposite signs and perpendicular to each other. So one will be 180 and 90. So we get this formula, or we get this power cross. This will be the same as combining as a spherocylindrical lens. The spherocylindrical lens will have a spherical power of plus 0.5 and a cylindrical power. The cylindrical power will be twice the sphere but of opposite sign. So it will the same, or the net result of this equation will be the same as the below one. So the upper one will be minus 0.5 in one meridian and the plus 0.5 in other meridian, and the below one will be minus 0.5 and the plus 0.5 in the other meridian. So they are be both the same. So we can just change with them, or change between them by transposition. So again, the sphere, the cross cylinder, it is either, or it is the same to say it is two cylinders of opposite signs and perpendicular to each other and of same power, or to say it is a spherocylindrical lens that has the cylinder twice the power of the sphere with the opposite sign. So again, the Jacksonian cross cylinder can be either 0.5 or 0.25. This will be the power of cylinder on the Jacksonian cross cylinder. The handle will be at a degree of 45 between either the minus power or the plus power. So the handle will be again 45 degrees. This is asked in the MCQ. The handle is 45 degrees between the axis of the minus power, as in red, or the axis of the plus power, which is in the black. So we said that we have two types of Jacksonian cross cylinder. Which one to use? If we have the patient vision, or if the patient best corrected visual acuity is 6.9 or better, we use the 0.25 diopter cylinder. So if the patient has a vision of less than 6.9, like 6.12 or worse, then we use the 0.5 diopter cylinder. And this is why. This is because if the patient has the vision of 6.9 or better, we need to improve. We need to do fine tuning of the vision with the smallest amount of cylinder that we have. But if the patient has a more worse visual acuity, like 636 for example, and then we place the Jacksonian cross cylinder of the smallest amount, which is the 0.25, the patient will not be able to appreciate the difference as we flip the cross cylinder in front of his eyes. This can be more vague now, but when we discuss the steps, you will understand this better. So we said that we need to understand, or or the Jacksonian cross cylinder can be used to identify the axis and the power. So what we do first, it is the discovery of the axis or discovery of the power. The first is to discover the axis. Then we will discover the power, and also this is asked in the MCQ. So to remember that A comes before P in the English alphabet. So axis comes before power. But why do we have to follow this order? This was found because a correct axis can be found in the presence of incorrect power. But the full cylindrical power cannot be found in the presence of incorrect axis. So if we find an axis that is not right or not correct, I still have a reliable result of the power. But the reverse is not true. So if I start with the power and my power calculation was wrong, then I will definitely have a wrong axis. So let's now see what are the steps in order to discover the axis of the cylinder of a patient that has a cylindrical lens in his trial frame or his glasses. First, we will put the cylindrical lens discovered during retinoscopy in the trial frame. Then we will occlude one eye and ask the patient to focus on the last line that is more clear with this eye. Then we will hold the Jacksonian cross cylinder with the handle parallel to the axis. Here is the keyword. We will put the handle parallel to the axis in the cylindrical lens in the trial frame. By making this, the red and white markings will be 45 degrees to the axis of the cylinder in the trial frame. So the plus and the minus cylinders will be at both sides of the cylindrical axis of the trial frame. Then we will flip the Jacksonian cross cylinder so that the red and white markings are reversed and ask the patient if there is any changes in the visual acuity. If the patient is see or reported that there is no difference in the visual acuity, then the axis of the cylindrical lens and the trial frame is correct. If the patient reports that there is improvement in one position, then we will check if what we are using, if we are using the minus cylinder or the plus cylinder. If you are using the minus cylinder, then we will move the minus cylindrical component or the red mark toward the cylindrical axis, or we will rotate the cylindrical axis toward the red mark. While if we are using a plus cylinder, then we will rotate the cylindrical axis toward the plus mark. And then we repeat again until the patient reports that there is no difference. So let's see an example. We performed retinoscopy on a patient, and the retinoscopy value is 1 diopter of a sphere and 1 diopter of a cylinder, axis 180, and the patient C69. And we check the spherical power by fogging and euchrome, and now we want to check the cylindrical axis. So we would start first by the cylindrical axis, and then we'll move to the cylindrical power. Here is the eye, and here is the minus lens. We use the minus cylindrical lens of -1 axis 180, and we want to check if this axis of 180 is the correct axis. So what can we do? We place the Jacksonian cross cylinder in front of the patient trial lens, but the condition here is that the trial lens frame or the handle is on the same axis of the trial lens axis. Again, so we put the handle on 180 of the trial lens that we need to make sure of its axis. And in such a condition, the minus and the plus axis of cylinders, like for example, here, like here, this is minus 0.5, and this is plus 0.5. They are both will be at about 45 degrees from the axis of the trial lens, as the handle is also at a 45 degrees from the minus and the plus, but it is in the same axis of the trial lens. So what happened next? After putting this orientation, now the patient has his trial axis at at 180, and he has minus above and plus below, and this is what we will call a position 1. So we ask the patient if position 1 is better or if we flip it. So if we flip it, the reverse will occur. The plus will be above and the minus will be below, and we will call this position number 2. So if the patient reported that the position number 1 is better, so he can see clearly while the cross cylinder is in position number 1 when the minus was above and the plus was below, then we will move the axis of the trial lens toward the relevant sign in the same direction. So the patient, we are using now a minus cylinder, and the patient reported that the position 1 is better, so we will move the axis of the minus cylinder toward the minus mark of the cross cylinder. So we will make it like this. So we will make the axis of the trial lens at 170, because position number 1 was much better. Then we will adjust the trial the Jacksonian cross cylinder axis to be in line with the new axis. So the new axis was 170, and we will adjust the trial length, the Jacksonian cross cylinder handle, to be in line with the new axis, and we will repeat the same process again by flipping the cross cylinder in front of the patient's eye and asking whether the position 1 is better or position 2. And if the patient say that they are equally blurred, so they shouldn't be good, they will be equally blurred, because they will just enlarge and small the circle of least confusion, but they will always be poor, or they will not be a good vision. So if the patient say that, okay, doctor, I don't like it and I see better without it, we will say, okay, we will know this. We know that you will see better without it, but we need to know if position 1 is better than position 2, or if there is any difference, because if we are equally blurred, this is our end point. We don't want much more than this, because if they are equally blurred, then we are on the correct axis. So if now he's saying that if we are flipping the cross cylinder again, then the patient say that, well, it will be the same, or the both positions 1 and 2 are equally blurred, then this will be the right axis of the patient. So we now have the axis of the cylindrical lens. So how to refine the axis? The patient responds that position 1 is more clear. So we rotate the cylindrical lens toward the position of the red mark, as we are using the minus cylinder. And in such case, which is position 1, initially we use steps of 10 degrees. Then as we get to the correct axis, we can use smaller steps as 5 degrees. So if the patient says that both images or both lenses are equally blurred, then this is mean that the patient cylindrical axis of the trial frame will match the patient cylindrical axis, so the true axis will be 170 degrees. Do you have any problem with the refining of the axis? I know that if you are hearing this for the first time, it will be difficult. So usually it is not understood from the first time. You need to listen to it several times, and I am going to post a video in the WhatsApp group for the whole process. You need to watch it, and you will, and by this it will become much more easier, and you will understand the whole process. And to confirm your understanding for this the Jacksonian cross cylinder, you need to practice it at your clinic. So let's continue the refinement of the power. So how to refine the power? It will be the same process, but with slight modifications. So we put the cylindrical lens discovered during retinoscopy in the trial frame, occlude one eye, and focus on the last line that is clear to the other eye. And then we will hold the Jacksonian cross cylinder with the red mark parallel to the axis of the minus cylinder, or the white mark at the axis of the plus cylinder. So in case of the power, in case of discovery of the power or adjustment of the power, we don't hold the Jacksonian cross cylinder with the handle with the axis. As we case, this is only in case of discovery of the axis. So we put the handle with the axis of the trial lens in case of if we want to adjust the axis. But if we want to adjust the power, we put the red mark or the white mark with the axis. So whether we are using a minus cylindrical lens, we put the red mark with it. If we are using a white cylindrical lens or a plus cylindrical lens, we put the white mark with it. Then we flip the Jacksonian cross cylinder in front of the patient's eye with reversing the red and the white markings, and ask the patient if they see any change in the visual acuity. If the patient has no difference and both images or both lenses are equally blurred, then we reach the final correction. If the patient says that there is a normal or there is an improvement in one position, then we will make a compensation or we will make a correction, as we will see now. So suppose that we are using the plus and minus 0.5 diopter Jacksonian cross cylinder, and we have the trial length is -1 sphere, minus 0.75 diopter of a cylinder, axis 120. So we make sure of the axis. By the first step, we adjust the axis, and we need now to adjust the cylindrical power. So what we need to do is putting the Jacksonian cross cylinder with the red mark aligned with the trial length axis, which is 120 and 20. And by this, we add minus 0.5 diopter to the already present minus 0.75. And then by flipping the cross cylinder, we switch between the minus 0.5 to the plus 0.5. So by switching, the white mark will be over the cylindrical trial length power, which then we will put plus 0.5 over the minus 0.75. So after this, we ask the patient if there is any position much more clear, and if the patient report that the red mark is better, then we will put we will increase the minus. If we will say the white mark is better, then we will increase the plus. Let's say for this example, let's say the refining the power. So if there is this is the cylindrical power, or this is the trial length, and this is the axis that was discovered by the first step of the Jacksonian cross cylinder, and now we put the Jacksonian cross cylinder, not the handle with the axis, but if they are using a minus cylinder, we will put the red mark with the axis of the trial length cylinder. If we are using a plus cylinder, we will use a plus, the white mark aligned with the axis of the plus cylinder. So here we are using a minus cylinder. It is so we use the red mark aligned with the axis. So ask the patient, is position number 1 is better or position number 2? Again, check. We are here now putting the minus over the minus, or the plus over the minus. Let's say, for example, if the patient says, okay, I found that this picture is much more better. So, but if the patient says that he can see much more better in this lens position, then we will add minus 0.5 over the cylinder, because when we put this position, the minus of the trial lens is added to the minus of the cross cylinder. But if the patient says that this position is better, when we are putting the plus over the cylindrical lens, then we will add the plus 0.5 to the cylinder of the trial lens frame. So now we adjust the cylinder. For example, let's say that the patient has -1 diopter sphere and the -0.75 diopter cylinder 120, and the patient prefers the red mark. So what will be the final refraction of the patient? So if you think that we will just add -0.5 to the cylinder, you will be wrong, because when we are adding a -0.5 diopter to the cylinder, we are now changing the spherical equivalent. As I told you in the first slide of the Jacksonian cross cylinder, the basic principle of the Jacksonian cross cylinder that it has a spherical equivalent of 0. So the cylinder has double the power of the sphere. So if you by switching the Jacksonian cross cylinder in front of the patient's eye, we just collapse and expand the circle of least confusion, but we don't change its position in relation to the retina. This sentence is very important and asked frequently in the MCQ. The Jacksonian cross cylinder just expand or collapse the conoid of Sturm, so that the circle of least confusion is always present on the retina. But if we put if we change the minus cylinder power without adjustment of the sphere, then we will change the circle of least confusion position in relation to the retina, and this will lead to that the principle of the Jacksonian cross cylinder will not be longer working. So what we do, we need is to adjust the sphere as well. So if we put minus the f 0.5 diopter cylinder at the cylindrical power, we need to put half of the cylindrical power in the sphere with the reverse sign. So if we put minus 0.5 diopter in the cylinder, we need to put plus 0.5 diopter in the sphere. And this is because by taking the spherical equivalent of plus 0.5 diopter sphere and the minus 0.5 diopter cylinder, the spherical equivalent of this will be 0. So the circle of least confusion will be the same on the retina and it will not change. So if we need to adjust the cylindrical power by cylinder, we need to modify the sphere as well in order to have the circle of least confusion on the retina. So the final refraction in this example will be minus 1 plus 0.25. It will be minus 0.75. The minus 0.75 diopter plus minus 0.5, then it will be minus 1.25 diopters in the axis of 120, and this will be the final refraction of the patient. So, would you like me to repeat it again? Hello? Okay. So here is the cross cylinder. So the cross cylinder is the most important topic or the most important part of the subjective refraction, and this is one of the most hot topics in the exam that's frequently asked, and you need to understand it well. And as I told you, I will send you a video in the WhatsApp group that will illustrate the whole process more clearly. Another method for identification of the astigmatism will be the astigmatic dial. You will find this photo in the chart of the visual acuity chart, and you may wonder what is its use. This is because this is called the astigmatic dial, which is used to identification if the patient has astigmatism or not. Meaning that if the patient has astigmatism and he sees this dial, he will find that there are some lines that are more clear and more dark than the others. And this clearly illustrates that the patient has astigmatism. So in this condition, or in this case, what we do first we do fogging to suspend the accommodation, and then we will test to the presence of astigmatism and determine its axis. So if a set of lines appears clearer or darker, then there is astigmatism, as we can see here. So we ask the patient if you can see any dark lines that are more clear than the others. He will say, okay, I can see that at 12 and 1 and 2 and 3 o'clock are more clear than the others. So we will know that there is astigmatism. And the axis of astigmatism is perpendicular to the axis of the dark lines. So if you see that, for example, that the 2 is the most dark one, so the axis of astigmatism will be at 10 and 4 o'clock. So this will be, or 11 and 5 o'clock. So the axis of astigmatism, or the axis of the cylindrical lens that we will correct the astigmatism, will be perpendicular to the axis of the dark line that the patient can see clearly, because as we all know that the cylindrical lens will correct the perpendicular meridian. Then, in order to measure the amount of astigmatism, the minus cylinder are placed in front of the eye with the axis perpendicular to the darker lines. So we will, for this example, we will put like -1, then -2, -3, -4, with the axis at 135, for example, because it will be more in conjunction with the 4 and the 10 o'clock axis, until the patient can see clearly, until that all lines are seen clearly. Then the minus sphere is added until we reach the best vision. So we can here adding -1 sphere, -2 sphere, -3 sphere, until the patient reach the best corrected visual acuity. So what can we do here? We do here what we do here by correction of the cylinder and the correction of the sphere is that this patient who has a cylindrical error has a conoid of term that has two focal lines. That will be a first focal line and second focal line, and in between all of them is the conoid of term. The idea of putting the cylindrical and the spherical power is to collapse this conoid of term so that these focal lines will coincide into a single point, which will represent the refractive error or the refractive correction of the patient. Finally, we have the stenopic slit, which is the final method to determine that the patient has a cylindrical error or not. So what is the stenopic slit? We can consider the stenopic slit as a modified version of the pinhole. So it is a trial lens frame that has a slit, and this slit will allow the patient to see only a slit image. So it can be used to determine the refraction and the principal axis of the astigmatism. So it allows only light that will pass through the slit to enter inside the eye. And when the slit lies in the one principal axis of the astigmatism, the second line focus is eliminated and the blur of conoid of Sturm is reduced, allowing to see a clear image. So let's say, for example, that the patient has astigmatism and the meridian of the greatest and lowest power will be at 90 and 180. So when we place the stenopic slit like this with the slit in the vertical meridian, so the patient will see a clear image at this meridian, and the image of the perpendicular meridian will be eliminated. So the patient will see a very bright image, and that's why we can say that the patient has an astigmatism in the axis of 100 and astigmatism of 90 degree. So we place the patient. Here is the stenopic slit is placed in the trial lens frame, and then by rotation of this knob, we still rotate until the patient reach the maximum vision. So we put a spherical lens. So the spherical lens has a same power in all meridians, and by rotation of this knob until the patient reports that there is a good position. Let's say, for example, that the patient says that at 90 degrees while the slit is vertical, the patient has the best vision. So the patient has an astigmatism in this meridian. Let's say that we now put a plus lens or plus lens and the minus lens until we reach the best correction or the best vision, and the patient has the best vision with +1 axis 90. So we make what's called a power cross like this, putting the +1 axis 90 in the vertical position. Then we will rotate the slit to the perpendicular. So if the patient has one position which is more clear at 90, then we will rotate the slit 90 degrees, so it will be at 180. Then again we put spherical corrections until the patient reach the maximum vision. So if the patient has the maximum vision of by -2, so we in the horizontal meridian or we in horizontal axis, we put the -2 axis 180 in the horizontal meridian. So the patient was corrected by 2 spherical lenses, and each one was in a different meridian. So this what we'll call, or what the result here is called, what's called the power cross. And in order to have the prescription from this power cross, this can be done by a simple way, by taking any number as a sphere. So for example, we take the +1 as a sphere, then the difference between both readings will be the cylinder. So -2 minus +1, it will be equal -3, and we will take the first reading axis as the axis of the cylinder. So in order to reach the prescription of the glasses from this formula, this will be +1 -3 axis 90. The same thing if we take the other reading as a sphere. So if we take the other reading as a sphere, -2, so it will be the sphere of -2. Then the difference between both readings will be the cylinder. So +1 minus -2, it will be +3. And we will take the first reading axis as the axis of cylinder. So it will be 180. And if you notice, this formula or this prescription will be the same like this, but it is just by transposition. So this is just a practical points, and you are unlikely to be asked in the exam, but this is just for your practice to know that the stereoscopic slit is another way in order to discover the cylinder. If you don't have a retinoscopy or you don't have an autoref, you can still know the power of the cylinder and the sphere of the patient by using the stereoscopic slit. So is it clear? Okay, so I guess that we will stop at this point. We will continue tomorrow. So there will be another lecture tomorrow in order to hurry up and catch to catch up the schedule of our schedule. So we will continue tomorrow the remaining parts of the human optics, and so that we can start the next week with the instruments, and this will be the last part of the optics.